Hola friends, I have been busy this new year. Check out this space shooter I built in Godot. That background is not a static image, it is a shader that reacts to the ship's location. It is actually way easier for beginners than using a pixel editor. Check out the firepower. It starts with a heavy forward burst, but then, boom, a 360-degree rotation firing in all directions. I used Cursor to help adapt this from a classic 2D Galaga style into a physics-based Geometry Wars vibe. The enemies track you, they shoot back, and the difficulty ramps up until your health hits 0. Even though Cursor in AI is limited when compared to JavaScript, the power of this language for making games more than makes up for it. Stick around because I am going to show you exactly how I used AI to build this game from scratch. Let's get into it. Wow! Okay, let's rewind. Before the fancy shaders, it looked like this. A rough prototype of a ship just blasting squares. To get here, I actually had to step away from the keyboard and pick up this book, Godot 4 Introduction to GDScript by Korotkin. And honestly, that is the biggest culture shock coming from web development. With Phaser and JavaScript, if you know how to code, you just open VS Code and dive in. You hack away. You make a canvas and you draw a sprite. It is intuitive, but Godot, it demands respect up front. You are going to have to do some actual reading. The IDE is incredibly powerful, but look at it. It is dense. It is very dense. You have the scene tree on the left, the inspector on the right, the file system at the bottom, and a million buttons in between. In Phaser, you control the structure. In Godot, you have to submit to its structure. You have to learn about nodes and scenes and signals. You have to learn that everything is a node. While GDScript is actually a very easy language to learn, knowing where to write that code and which node to attach it to requires that upfront study time. It is easy to do anything you want eventually. But unlike JavaScript libraries where you just start typing, Godot forces you to learn its architecture first. So if you are coming from web dev, keep that in mind. The initial velocity is slower and you might feel stuck reading docs for a few days. But the momentum you build later is massive. This is where Godot's scene system really clicks. I took that entire space shooter I just showed you and I wrapped it up into a single object. It isn't the whole game anymore, it is just a minigame. I created a new overworld scene and dropped in a wolf sprite. Now, when the wolf wanders around, the code pauses the overworld and loads that space battle scene seamlessly. To make the world look real, I had to wrestle with tile maps and sprite sheets. It took a minute to figure out the slicing and the layers, but once you understand that everything in Godot is just a scene inside another scene, the whole engine starts to make sense. Now we need to make this overworld actually feel like a game, so things are about to get a little more complicated. I started utilizing sprite tile maps to paint the ground and create a layout. In Godot, sprite sheets are absolutely critical, especially when you are working with sprite tile maps. That is how you build out your entire world efficiently. However, setting up the collision, the physics layers, and the terrain sets in Godot can get really complicated. I am not going to cover all that here. I highly recommend you go find a dedicated YouTube video just on Godot tile maps. It is a dense topic, but it is worth learning properly. I also decided to ditch the random encounter logic. Instead, I wanted specific gates and door areas to trigger the battle. This is where the Godot IDE really shines. Linking these events is surprisingly easy. I just set up a trigger area on a door sprite, basically an invisible box, and told the engine, when the player enters this box, load the space shooter scene. I didn't have to write a complex event listener manager, I just connected a signal in the editor. I also populated the world with obstacles like trees and crates. I didn't want the player walking through them. In a framework like Phaser, you might have to configure physics bodies manually. Here, I just added collision shapes and Godot handles the blocking automatically. It just works. But let's address the elephant in the room. Just because the code works doesn't mean it looks good. It is really hard to just instantly be good at pixel art and sprite design. As you can see, my early draft here looks pretty bad. The perspective is weird and the styles clash. But that is the reality of solo dev. Get the logic working first, make it pretty later. If you think you can just download Godot and figure it out on the fly, stop. It is not going to turn out well. Godot is not intuitive in that way. I leaned heavily on 3 resources to get my head around this engine. Godot 4 Introduction to GDScript by Korotkin, Learning GDScript by Developing a Game with Godot 4 by Sander Van Hove, and Beginning Game Development with Godot by Mythili Dule. Read them. Seriously, you cannot just wing the architecture of a Godot project. But once you understand the basics, how do you speed things up? This is where my AI workflow comes in. I don't use the built-in script editor for everything. I open the entire Godot project folder inside of Cursor IDE. I use Cursor to write the logic and handle the heavy lifting, then I switch back to the Godot editor to handle the visual stuff like tile maps and nodes. And honestly, this workflow is much better than when I was building games in Phaser and JavaScript. When I was doing the JavaScript route, Cursor would just pump out file after file. It was fast, but I felt detached. I was vibe coding, but I didn't actually know how anything worked. As the game got bigger, the amount of unknown code became unwieldy. With Godot, the AI can't do everything. It can't wire up your signals or paint your terrain. You have to get your hands dirty. It forces a perfect balance. The AI helps you code, but Godot forces you to actually be a developer. Part 1, the starter kit strategy. Now that we understand the basics, the nodes, the scenes, the signals, we can stop doing things the hard way. One of the coolest features of the Godot ecosystem is the asset library. I didn't want to code basic movement from scratch again, so I started with this, the Godot 2D Space Shooter Starter Kit. You can find the repo on GitHub. It gives you a fully functional Galaga-style game right out of the box. It has a player, it has enemies, and it has a score system. This is the secret weapon of solo devs. Don't reinvent the wheel, load a starter kit. Once I had this codebase loaded into Cursor, I could tell the AI, okay, this is cool, but I don't want Galaga, I want Geometry Wars. I had the AI strip out the restricted movement and replace it with physics-based inertia. We kept the bones of the project, the hitboxes and the scene structure, but completely swapped the gameplay logic in about 20 minutes. Part 2, the shader background with the movement fixed, we hit a visual problem. The default starter kit uses a static PNG of stars that just scrolls vertically. That works for a game that only goes up, but since our ship now flies 360 degrees, that static image breaks the illusion immediately. This brings me to my absolute favorite feature of this engine, Godot shaders. In my first attempt, I tried using a massive widescreen PNG, but the file size was huge and it eventually ran out of space. I thought about using a tile map, but that takes forever to paint. The solution is code. I replaced the background image with a shader material. This isn't a picture of stars, it is a math formula that draws stars. It listens to the player's coordinate position and shifts the stars in the opposite direction. It is infinite, it is lightweight, and it makes the game feel responsive and alive in a way that a static image never could. A great feature of Godot is its awesome community, and with shaders there is a really awesome site called godotshaders.com. I highly recommend you check that out. It is where I got the starting code for the space background I'm using in this new example. So we have the new movement code and that cool shader background, but jamming them together wasn't exactly smooth. This phase was just a lot of mucking around in the Godot Editor. See, Cursor is great at logic, but it has terrible spatial awareness. It wrote the code for the UI, but when I ran it, everything was off-center and wonky. The AI doesn't know where your screen edges are visually. I had to stop coding, go back into the Godot IDE, and manually drag the anchors and align the containers to get it looking clean. You can't vibe code your way out of a bad UI, you just have to fix it by hand. Then there was the issue with the bullets. Remember, this started as a Galaga clone. The bullet speed and spread were tuned to fire slowly straight up. In a Geometry Wars style game, that feels sluggish and weak. I had to go into the inspector and crank up the projectile velocity and randomize the spread angle to get that snappy, chaotic feel. And finally, it clicks. We have the rotation locked in, the bullets are spraying in that satisfying burst pattern, and the shader background is reacting perfectly to every move. It is no longer just a Galaga clone, it is a fully functional, cool-looking arcade shooter. It is a really great starting point that we can actually build a full RPG around. The plan finally came together, and speaking of building tools, if you are wondering how I made this video, I actually used a custom Python tool I am developing called TTS Blender. It helps mix and master these AI voiceovers automatically. I have been improving it alongside the game, so if you are interested in that or the Godot books or the starter kit, links to everything are in the video description. I have had a really fun time creating this project. As far as a newbie learning to build a game goes, I think this project was much more successful than when I tried to build a game in JavaScript. I really like the way Godot limits how much vibe coding you can use. It prevents things from getting out of hand. And the Godot IDE is so powerful for building games. Whether it's building levels, shader backgrounds, or using the powerful GDScript, it is really a great ecosystem. I'm going to put up a couple previews of the idea for what the game is going to look like when if I ever get it finished. The basic concept is that the player gets trapped in a haunted evil retro arcade from the 1990s era. The only way to escape the arcade is to play through the various mini-games to advance deeper and uncover the mysteries. Godot and the way it builds and handles scenes is perfect for this, and I really think the project could be pretty cool. If you want to see that progress, please subscribe to stay updated with what is happening on the channel. So where's all this actually going? What you just saw, that space shooter, that is just one cabinet. The real project isn't just a shooter, it is an atmosphere. Imagine a dark room, the hum of neon signs, and the smell of ozone and old carpet. In the final game, you are trapped in a haunted retro 1990s arcade. The space shooter we just built, you have to beat the high score on that machine just to unlock the door to the next room. Every cabinet is a different genre and every room gets darker. You have to beat the games to survive the arcade and uncover why you are trapped here. This is the Arcade of the Lost, and I can't wait to show you what comes next. So please subscribe and like the video and leave comments and whatever. Even if you hated everything, still give me something, please. I would really appreciate your comments, thoughts, ideas, whatever you want to share. I am here for it. Alright, well yeah, I appreciate you watching the video. I hope you come back for the future installments. Thanks for leaving.